I'm Trevor Benson.
I'm Richard Chan.
I'm Joshua Chillicurry.
And I'm Aditya Sa.
And this is our project, ARES-M. ARES is a compact weather sensing unit designed to be placed on the rocky terrain of Mars to capture environmental patterns in often overlooked and underrepresented areas of the planet.
By connecting sensing hardware to a live front-end dashboard, ARES is able to capture data on seismic activity, soil moisture, temperature, humidity, and even light wavelengths to model natural phenomena on Mars.
Well, what inspired us and how do we build it?
Humans have been trying to uncover Mars' secrets for decades. When NASA landed its first robotic rover, Sojourner, on the red planet's surface, we embarked on a journey to monitor, interpret, and compare Mars' complex natural phenomena to our very own Earth. While NASA's Curiosity rover has an environmental monitoring system, this device can only track weather at one place in time. Similarly, their InSight lander can effectively monitor multiple environmental metrics, but is bulky, expensive, and lacks coverage. We developed ARES to address these problems. Its pods can be deployed and connected through a mesh network, creating a working interface for localized weather measurements in a region. Here's how it was built.
Using advanced I2C communication protocols, we've been able to develop a custom code base capable of handling data from multiple kinds of sensors at the same time.
We've connected these pods together through a mesh network system to make it low power and integrate these systems effectively to update the live dashboard.
You can see we have two data structures here. First is the station data structure, and then second is the weather data where we store our measurements. You can see we have the timestamp down here. In our route.ts, we use a post handler to collect data from the ARES sensor.
Additionally, for the front end, this is an example of a chart component that allows us to generate charts from the data, and all of these components were compiled into the web UI on page.tsx, which used Tailwind CSS for inline styling.
This is a simulation of earthquake conditions on Mars. This is a soil moisture sensor, which works by measuring the capacitance of electricity in the water. This is a heat gun used to simulate increases in temperature and humidity. As you can see, in just 2 days, we've created an entire embedded system that is able to detect advanced environmental patterns and hooked it up to a fully functional front end.